Hello, welcome to this lesson of our study of theoretical mechanics. Okay, so if you have not subscribed to my channel, kindly subscribe to support the channel. Okay, in this lesson, what we'll do is you just go through how to calculate some quantities in particles that are involved in motions. Okay, all right, so let's start. Now the first one is a particle of mass m, so you have to underline that one as well. Okay, if you underline this mass m, moves in a plane and has position vector that, okay, where r and theta are polar coordinates. Okay, find the kinetic energy of the particle. Okay, Ke. Second one is what is the angular momentum of L of the particle, which is L. Okay, so let's go and write information that we have. So the information is that we have mass m, and in polar coordinates, r is given by r cap. Okay, there is a proof to all these, but in this context we will not go through them. But if you want a video for me to explain, and if you still need it, yes, I will have to do a video on that for you. Okay, so if you want a video for me to explain all these and walk you through how to get them, then I will do that for you. Okay, then velocity is also given as this. Now these ones are very important. The velocity is r dot. The first one is the dot at the top there is very important. This dot, okay, we have some y dot there, r dot r cap plus r theta dot theta cap. And second one is this one. Okay, that is the acceleration. Every dot in it is very important. Okay, the acceleration is r dot dot minus r theta dot squared into bracket r cap plus 2 r dot theta dot plus r dot dot theta cap. Okay, like I said, it's very simple to prove all of these. It's very, very simple, trust me. But like I'm saying, we shouldn't worry about them. All you need to do is just try to keep these in mind. Okay, now the first question A is saying that we should find the kinetic energy, where you know that Ke is equal to half mv squared. And in doing this motion, please try to always remember your formulas, because it's very, very important. But v is given as a vector here. Okay, but you know that if you have a vector v, then v squared mean that v, the vector v dot itself. Okay, so you pick the vector v here because there is a v square in the kinetic energy, and we can't deal with that unless we try to find a v squared. So v squared will be equal to r dot r cap plus r theta dot theta cap. Okay, dot, it's a dot product, r dot r cap, okay, plus r theta dot theta cap. Okay, now dot two vectors, you are saying that these r cap and theta cap, they are unit vectors. Okay, so they are dot product. When you dot r dot and theta dots, when you multiply them, you get 0. When you multiply theta dot and r cap and theta cap, you get 0. But when you multiply r cap and r cap, you get 1. Okay, so it's like the normal dot product that you know. So this will be equal to just taking individual components and multiplying them. So r dot times r dot, you get r dot squared plus, you take r theta dot times r theta dot. That is how you do dot product, right? So you do r squared theta dot squared. Okay, it becomes r theta dot times r theta dot, and that will be r squared theta dot squared. Okay, and the first one, so you have r dot times r dot, and that is r dot squared. So this is your v squared. So it means that my kinetic energy Ke is very simple like that: half m into r dot squared plus r squared theta dot squared. Okay, I hope you get this. So this is your kinetic energy. Very, very simple like that. Okay, now let's move on to the next question. The next question B is saying that we should find the angular momentum L, and then L is equal to r cross the vector r cross p. Okay, this is your question, okay, that you're supposed to find the angular momentum. And so, like I said, the angular momentum is given by this, but P, we know, is equal to mass times velocity, okay, and the velocity vector V is given by r dot r cap plus r theta dot theta cap, okay. So mv, which is P, will just be equal to, the mass is still m, we said it's m, so we have m r dot r cap plus m r theta dot theta cap. Okay, so when you cross r and v, r and p, and r is equal to r cap, okay, some books will use real, that r is equal to real cap, and that would be very simple for us, but here the question is maintaining the polar component, that is the real in terms of r, okay. So what you do here is you simply cross the two of them, but realize that to do a cross product you need three components. So you have this in the r component, theta component, but you don't have the last component. So let's call the last component z, so that we can write our r in terms of three dimensions as r cap, okay, plus 0 theta cap, okay, plus 0 z. Let's call the last component z. Then our p, that is the momentum, will be equal to mr dot r cap plus mr theta dot theta cap plus 0 z. When you cross the two of them, when you're doing a cross product, okay, let me show you some shortcuts. You pick the first vector, that is the r, then you start writing from its j component, or the middle component, this one, okay. So you write 0. Okay, I'll use this for almost every question that involves cross product, okay. So try to understand, but if you don't understand, just go by the normal way of doing a cross product, okay. So have 0, then write the next component, that is the z component, 0, and come and write the first component, r, then write the last component back again. So let me write the r here, then write the last component we started, that is a 0. Okay, with the r cap, theta cap, and the rest, just leave them. So let me call this z cap rather than the z, okay. So you come to, this is the first vector. Like I said, you start writing from the middle component of the first one, that is a 0, okay. Then go to the second, the third one, that is a 0. So it's like from this side coming back to the middle, okay. I hope you get the point. So now you go to the second one, you do the same thing to it. You write from the middle, and the middle is what? M r theta dot. Okay, then you go to the last one, that is the z component, you have 0. Come to the first component, m r dot, okay, is m r dot. Then you end at where you started, so m r theta dot, okay. Now the solution, the cross product of this is very simple. You do this times this, okay, minus this times that, and that is the first component, okay. So 0 times 0 minus m r theta dot times 0, and that will give you still 0 r cap, okay. Then you go to the next one. This one you do plus, then this times this minus this times that, okay. So we realize that the multiplication goes this way. You first pick this and this, then you do that, you subtract from the other one and come to this one. So 0 times this is 0 minus this times that is also 0. So you still have 0 theta cap, and plus this times this, so it becomes r m r theta dot, okay. And that becomes then minus this, okay, this time that will give me 0. So I have m r squared theta dot in the k direction. So this solution is very simple, m r squared theta dot in the k direction. That is the angular momentum for you, okay. I hope you get it. Like I use Z, okay, I use Z, but I'm writing K, and you can bear with me that the last component is just K. Okay, you can do that, or you can still write it, maintain it as Z. So in terms of your exams, however your lecturer or your teacher want you to keep it, then you keep it like that. Okay. And the next question is: a particle of unit mass moving in a space has position vector r being equal to r of rho, phi, z, where phi, rho, and then the z are cylindrical polar coordinates. Okay, but here there should be something we should note. The unit mass is very important. Unit mass means that the mass is equal to 1. Okay, now the first question is: find v rho, the real component of the velocity. So in what I wrote for you first, I said that in polar coordinates, these are your velocity, this is your position vector, and this is your acceleration. So we should also write the same thing for cylindrical coordinates. So in cylindrical coordinates, your r is given by rho cap plus z k. Okay, and then your velocity is given by rho cap, the same thing like the polar coordinate, plus rho phi cap. Okay, phi cap plus z k. Okay, then your acceleration is the same thing. The first two terms are always the same for polar and cylindrical. The first two terms are the same. There's in the cylindrical, there's a z component attached to it. Okay, so this time around you have the acceleration to be rho okay, minus rho phi squared, then rho cap, okay, plus 2 rho phi okay, is it okay, plus another rho phi okay, then phi cap plus z k. Now the first question is to find the v rho. Okay, so question 1, to find v rho, meaning that the velocity, the component of the velocity in the rho direction, that is the component or the coefficient of rho cap, and that is equal to rho dots. Very simple like that. Okay, now the question 2 is kinetic energy, and we just did it in the first question. That is equal to half mv squared. But like I said in the question said the particle is a unit mass. It has a unit mass, meaning that mass is equal to 1 kilograms. Okay, unit. This implies we have half times mass, which is 1, times v squared. And I said that v squared is the dot product of itself. So let me dot this by itself. It's simply taking each component, then squaring them. Then you add all of them. So rho dot squared. Okay. You square each component, then you add them, plus rho squared phi squared, then plus z squared. This is simply your kinetic energy. Okay. And the third question is find the component of the acceleration in the phi direction. Okay, acceleration in the phi direction. So you come to the acceleration, look through it. Where is your phi? The phi cap is here. Okay, so we look at the component there. So the third one, or the C, is a phi. Okay, is equal to 2 rho phi plus rho phi dots. Okay, that is all. Very simple. These solutions are very, very simple, right? So let's go to the next question. Now the position of a particle of mass 2 kilogram at any time t is given by, so the position is r of t is equal to t, this one, the underlined one, t sine ti plus cos 2 tj, then plus sine squared tk. Okay, so keep this. Now the first question is calculate the momentum of the particle. Okay. You should calculate the momentum of the particle at time t equals pi over 2 seconds. And the second is determine the impulse of the force on the particle between the times t equals pi over 2 seconds and t equals pi seconds. So what you do is you write your position vector back. The position is given by t sine t I and plus cos 2t j, then plus sine squared t k. And in the question we said that the mass is equal to 2 kilograms. You should always write your informations that you have. Okay, now the first question is momentum. The first question A is asking us to find momentum. Momentum is actually P is equal to mass times velocity. Okay, but given the position vector, what is your velocity? Velocity is just the differential of the position vector with respect to time. Okay, so V is simply equal to dr dt, and this is equal to, now if I differentiate the first term, I have t sine t, so I have to use product rule. So differentiating t and keeping sine, I'll get sine t, plus differentiating the sine, keeping t, so I have t cos t, then I have I, okay, plus differentiating the second term. Realize the second term is cos, so when you differentiate cos, you get minus of sine. Then you differentiate whatever that is here, and you get 2. So minus 2 sine of the expression back. Okay. Then you come to this one, plus the differential of sine squared t. Now sine squared t, okay, can be written as sine squared t can be written as sine t all squared. So you use chain rule, that you differentiate this, looking at this as, let's say, u, the whole of this as u. So you have 2u, then times the differential of u. Okay, differential of u is that u is now sine, so you differentiate sine, you get cos t. Then you write your u back. Your u is what? Sine t. So this will give you 2 sine t cos t. Okay, I hope you get this. So let's erase it and write it here in addition to our velocity. So 2 sine t cos t. Okay, 2 sine of t cos t. So my velocity now is equal to sine, so there's a k here, sorry, sine t plus t cos t, then I minus 2 sine 2t j, and plus 2 sine t cos t k. So the momentum is, or the question is, we should find the momentum of the particle at t equals pi over 2 seconds. Okay, so we realize that the velocity is in terms of time t, so you have to evaluate this velocity at a time t equals pi over 2 seconds. Okay, and if you don't want any trouble, you convert your calculator to radians. And how to convert is just point shift on your calculator. Okay, then you press mode, then within that you get radians. Okay, let me pick my calculator and check the radians number. So you have shift plus mode, then within that the radians is 4, so you put your calculator on 4, that is radians, so that we use the pi straight away. But if you don't want to use the pi, then you realize that pi is still 180. Okay, so pi over 2 is 90. So therefore your velocity evaluated at pi over 2, okay, will be equal to sine of pi over 2, and if you use radians, it's still 1. Okay, if you use degrees, just 90, so sine 90 is 1. So I have 1 plus pi over 2 times cos pi over 2. Cos pi over 2 is 0. Okay, then I, then minus 2 sine of 2t, and t is what? Pi over 2, so sine of 2 times pi over 2. 2 times pi over 2 give you just pi. and sine of pi is the same as sine of 180, and that is 0. Okay, and in radians, sine of pi will still give you 0. So know which mode you keep your calculator in. So plus 2 into sine of pi, we said is 0, so we have 0, times cos pi. Cos pi is pi over 2, sine of pi over 2 rather. Okay, so sine of pi over 2 here is just 1. Then cos pi over 2, cos of pi over 2 is 0. That is cos 90. So you realize that in effect you have v of pi over 2 to be just I. Okay, you have one I just like that. So it means your momentum at that time will be equal to mass, which is 2 kilogram times I, and that will give you 2I. Very simple like that. Okay. Now you go to the next question, which says that we should determine the impulse of the force on a particle between the times t equals this and t equals that. Okay. So if you remember, like I said, I told you that there are plenty formulas you should know, but I hope that at the end of this lesson you'll be able to know most of the formulas. Okay, so the first formula you should know is this, that impulse from this equation, F equals mv over t. Okay, the impulse here is ft, and that is equal to mv. Okay, and in some cases you can also get, this is the impulse ft. Okay, you can also get impulse to be in continuous functions. Impulse should also be equal to integral of f times dt from some t0 to tn or t1. Okay, so if you know your function for your force, we can use this equation to go, that we know t0 to be equal to, from this question, t0 is pi over 2 and t1 is this. Then you have to come and use this equation to find the position equation to find our force, which is equal to mass times acceleration. So it means that we have to differentiate the v again to get our acceleration, multiply by mass, then go ahead and integrate the force to get that, but that will give us a tough time. Okay, but realize that from Newton's second law of motion, it states that the change of the rate of change of acceleration, or the rate of change of velocity, okay, let me put it that way, is in the direction of the force. Okay, so that is this equation, that is what it's all about. Okay, is it the rate of change of linear momentum or something like? Yeah, it's the rate of change of linear momentum. Sorry. So there is a change in linear momentum, but we are saying that this ft is equal to the impulse. It means that momentum is still equal to the impulse. So meaning that the time at time t1 equals, or t0 equals pi over 2, and time t1 equals pi. I think that is what they, yes. This, it means we have some change in momentum in the ft. So it means ft can also be written as change in momentum. Okay, which will be equal to p2 minus, or p1 minus p0. This case we use that p1 minus p0. So this will be very fast for us. Okay, rather than going to do the integration. So what will happen is you find p1 will just be equal to the m times the velocity evaluated at t1. Okay, and then p0 will be equal to mass times velocity evaluated at t0, and the mass times acceleration, so velocity evaluated at t0, that is t0 equals pi over 2. We already know this, that the momentum at that point is equal to 2I. Okay, I hope you get this. We already know this because that was the second question asked, or the first question asked, and we said we should evaluate the momentum at time t equals pi over 2, and lucky enough, this our t0 is pi over 2, and that is it. Okay, so if you go ahead and write your velocity function, the velocity function is given by, let me go ahead and write it here, is this. Okay, this is the velocity function. Let me use a red pen for it. This is it. So let's evaluate this velocity function at t equals t1, v of t1. Okay, so that we use it straight. Okay, and that is v of pi, and this will be equal to what? Now sine of pi, like I said, punch it on your calculator. Sine of pi is simply 0. T, that is, here you have t cos t. Okay, so wherever you see t, you put pi there. Pi cos pi is minus 1, and so that will give you minus pi I. Okay, like I said, the sine of pi is 0. So you go to the sine of 2 pi here, the second point, put pi in place of t. Sine of 2 pi is also 0, so I have plus 0 j. Then sine of pi is 0. Okay, so you make here 2 to be 0, so I have plus 0k. So in effect, I have v of t1 should be equal to minus pi I. So you go back to what we are doing and realize that v of t1, p1 will be equal to m times v of t1. Okay, and that will be equal to, we said we had what, v1 to be minus pi I. Okay, so we put it there. Mass is also 2, so 2 into minus pi I. Okay, and this will give me p1 to be equal to minus 2 pi I. So simply our impulse, which is the ft, will then be equal to the difference of these, so minus 2 pi I minus the p naught, which is equal to 2I. Okay, so in effect I have minus 2 pi minus 2 then I, or somebody can also write it as minus 2 out pi plus 1 I. However you see it in the equation, or you leave it in your solution, that is also right. I hope you got this. So that is the impulse for this particular question. So you can go ahead and use the integration way. The one that says we have to go and find your force using acceleration. So acceleration is just, so the F is equal to m dv dt. So you write your velocity function, you differentiate it again. Okay, differentiate the velocity function, then you integrate from t naught, and t naught is pi over 2, to t1, which is pi, and that should also give you the same solution. Now the fourth one is the acceleration of a particle of unit mass. Okay, the acceleration of a particle of unit mass is given by this. Okay, so you should always take note, the unit mass is very important. It means mass is equal to 1, and acceleration is given by this, 2I plus t minus 2j plus k. Now the particle starts from the origin with initial velocity I minus 2j. So it starts from the origin, meaning that the starting point t, the time, is equal to 0, and that the position at the starting point r is equal to 0 I plus 0j plus 0k. So it's 0 0 0 like that. Okay, so now let's start. The first question is to calculate the power delivered by the force on the particle at time t equals 2 seconds. And the second question is to determine the angular momentum of the particle at time t equals 1 second. So let's start. So information that we have here is mass is equal to 1, and that our acceleration is also given by 2I plus t minus 2j plus k. And we said that at the starting point t is equal to 0, and the velocity there at time t equals 0 is given by I minus 2j, with r at t equals 0. That is you said it started from the origin, and the origin, the position there we know is 0 0 0. So we keep these. Okay, and first question is find the power. Okay, and power, you know, is equal to work done over time. Okay, work done over time, and work done is also giving us force times distance. Okay, let me say r, F dot r over t. But what is this? F dot r over t. This can be written as that, and you know that this becomes f dot v, because your r over t is your velocity in terms of discrete how do I call it, functions. Okay, I hope you get this point. So let's try to find our force and also try to find our velocity. We know that the mass is a unit mass, so mass equals 1, and acceleration is that. So this simply means that our F is equal to mass times A, and then since mass is 1, we have the force to be the same as the acceleration. Okay, T minus 2J plus K. This is your force. Then your velocity, from this, let me code this for you. We know that A is the differential of velocity. Okay, so this will imply that my dv will be equal to A dt. This shows that v is equal to the integral of A with respect to t. Okay, so remember that. And also we know that v is equal to dr dt, which implies also that the r will be the integral of v with respect to t. So my v is equal to integral of A with respect to t, which is equal to integrating A. Wherever I see, let's say 2i, I integrate it with respect to t, and that will give me 2ti. I integrate t minus 2j with respect to t. The first term t I integrate, I'll get plus half t squared minus the second term 2, which will give me 2tj. So just integrate them term wise like that. Plus integrate 1k with respect to t, and you have just tk. Okay, then after integration, you know that we get a constant A. Okay, that is your velocity. But from the question, we said velocity at time t equals 0 is equal to I minus 2j. So in order to find our constant A, we should use this condition. Okay, this implies that my v of 0, that is at time t equals 0, should be equal to 2 into 0 I plus half into 0 squared, which is 0, minus 2 into 0, then j plus 0k plus A. Okay, and realize that everything here is 0 because all of them are multiplied by t, and I have 0 0 0 like that. Okay, so I have everything here to be 0 plus A, and we are saying this should be equal to this I minus 2j from the question. So meaning my A is simply equal to I minus 2j, which will also say that our velocity at any time t is equal to 2ti plus half t squared minus 2t j plus tk, then plus our A, which is I minus 2j. So you can actually go ahead and group like that and make sure that all your t's, all your i's are in one direction or are in one place, and in effect we have something like this, that my velocity v of t is equal to 2t plus 1, then I plus half t squared minus 2t minus 2, then j plus tk. Okay, so this should be your final one as your velocity. Okay, and there's my force. So I'm almost done because the power is simply F dot V. But remember, we are saying that we should find the power at time t equals what? So at time t equals 2 seconds. Okay, so you have to simplify. Some people didn't simplify, and then you get a very tedious one. So I have to simplify my force at time t equals 2. So at time t equals 2, F of 2 seconds will be equal to just 2i plus, putting 2 here will give me 2 minus 2j. I'm using the force equation, okay, or force vector. So I have 0j plus k. Then I go to the v at time 2 equals 2 seconds. I have v of 2 to be equal to 3i I hope it's no, it's 2 times 2, which is 5. Sorry, 4 plus 1, that will give me 5. 5i, then this, when I simplify the j component or the j component, I get minus 4j, then plus 2k, meaning that my power, okay, which is equal to the power which is equal to f dot v is simply dotting these two vectors, okay, and the dot product of two vectors is just multiplying the components, then you sum them. 2 times 5 plus 0 times negative 4 plus 1 times 2, okay, and 2 times 5 is 10 plus 0 times 4 is 0, 1 times 2 is also 2, so 10 plus 0 plus 2 give me 12, okay, so the power here is 12 watts, okay, or you can say 12, okay, the power is 12 here. Now the next question is, we're supposed to determine the angular momentum of the particle at time t equals 1 second. So we said angular momentum L is equal to R cross P. And since we know V, we can find our P. Our P is simply equal to mass times velocity, okay? And now the velocity is equal to, the velocity was given as what? This one, okay? So don't throw it away, you keep it there. And if you remember, the question is saying that we should find the angular momentum at time t equals 1 second. So it means that we should evaluate the velocity at time t equals 1 second. Now the velocity is equal to, let me write it well for you, 2t plus 1, right? 2t plus 1i, then the jth component is 1 over 2t squared minus 2t minus 2j plus ck, okay? So at time t equals 1, the mass is also equal to 1, so it means that my momentum is still equal to v, and it's equal to what? At time t equals 1, I have 2 times 1 plus 1, that will give me what? 3, right? That will give me 3. So the momentum will be equal to 3i, then plus, when I simplify the one in the bracket, what would I get? I'll get minus, okay, so it will be minus. When I simplify the whole of this, I get minus 7 over 2j, then plus k, okay? I hope you get this, so you can keep this as your momentum. Now, to find your R is equal to, like I said, the R dt is equal to V. So if I want R, then R will be equal to the integral of velocity rather. Okay, so R is equal to integral of V dt. And this will give me integrating V. That is, wherever I see the components I see, then I just take them and integrate them. So I have 2 over 3, right? 2 over 2, yeah, 2 over 2 rather. 2 over 2 t squared plus t, then I plus, now I have 1 over 2 here in the jth component, then I integrate t squared, I'll have 1 over 3 t squared, t cubed, then minus 2 over 2 t squared minus 2t j, okay, plus half t squared k. So realize that some will be cancelling out, so this will take this away. I have this taking this away, and that is all, okay? So my R position vector is equal to t squared plus t, then I plus, this one is just multiplying this, okay, plus 1 over 6 t cubed minus t squared minus 2t, then j plus 1 over 2 t squared k. So what will happen is that we have to simplify the like we did for the velocity. We've simplified the momentum at time t equals 1 second. So at time t equals 1 second, what will be my position vector? Before that, after the integration, there was supposed to be a constant a here, okay, or a certain constant b. Now you realize that in the question you said that it started from the origin at time t equals 0, r is equals to 0, 0. When you use those conditions to find your constant a, you get 0 for a. A will be equal to 0, 0. So that is why I didn't actually add it. Now when you do that, r of t equals 1 second, okay, t equals 1 second, that will give me 2i minus 17 over 6j plus 1 over 2k. That is your at time t equals 1 second. This is your r. So my momentum there at that point is also equal to momentum. You said is 3i minus 7 over 2j, okay, plus k. And we said that the angular momentum L is equal to r cross p. And this is simply equal to, like I said, you pick your r right from the second term going, 17 over 6, 1 over 2, then minus 17 over 6. Then you come to the momentum, you start writing from the second term, minus 7 over 2, 1, 3, minus 7 over 2. And the solution will be the product of this and this minus the product of this and that. That will be the first term. Okay, and that will give me minus 13 over 12i. Then you come to this and this minus this and that, okay? And that will also give me minus 1 over 2j. Then this times this minus this times that, okay? I don't know, but you can also go through them, point it on a calculator, and this is what you get, okay? So this is your angular momentum for the particular question we're talking about, okay? Now let's go to the next question. The next question is: a particle of unit mass moving in a space has parametric equations given by this. So the unit mass, you should analyze that, meaning that what the mass is what? 1. Okay, 1 kilogram. It has these parametric equations, okay? So x is like that and y is this, and then z is also equal to t cubed. Calculate the impulse, okay? These, we are saying that if you calculate the impulse of the particle in the first second of its motion, the first second means that t is equal to 1 second, okay? Time t is equal to 1 second. Determine the work done by the force in the first 2 seconds. We mean that the work done at time t equals 2, okay? So let's start. The information that we have is the unit mass. So mass is equal to 1 second. And then we have x is equal to t squared plus t plus 1. Y is equal to 2t, and z is equal to t cubed, okay? So with this, it means that my position vector r is equal to just xi plus yj plus zk, and that is t squared plus t plus 1 I plus 2tj plus t cubed k. That's your position vector. So the impulse, like I said, the impulse is somehow the same as the linear momentum, okay? So impulse ft is equal to m times velocity, mass times velocity v. Now the velocity is equal to what? So your v is equal to dr dt, and that will give me the differential of r is 2t plus 1 and I plus 2j plus 3t squared k. I hope you get this. So we should find the impulse at the first second, meaning that at t equals 1, what will be my impulse? Mass is equal to 1. Then it means my impulse ft is equal to 1 into velocity evaluated at 1, okay? So I have, when I evaluate this at 1, I have 3i And when I evaluate this one too, as there's no t there, so I have 2j. Then here will give me plus 3k. So this is your impulse. Very simple like that, okay? 1 times that, and it's the same thing. 3i plus 2j plus 3k. And now the next question is, you find the work done. The question is, what is work done? Work done is equal to force times distance. Okay. So if I'm supposed to go ahead and find my force and the whole lot, I think I'll be messing up. So what I have to do is just ask myself, which kind of energy would I be? The unit of force is what's energy. Okay, so in some cases we use a particular energy to represent the force. We use a particular energy to represent the work done by a force. Okay, so what will happen here is that we know that the kinetic energy can be calculated, and that is equal to half mv squared. Meaning I can use that idea to find my kinetic energy, and that will be the work done. Okay, and this will be equal to half into, we said mass is 1, and this one is at time t equals 2. So I have to come and evaluate velocity at time t equals 2. Okay, at time t equals 2, let me write my velocity. Velocity is equal to, the velocity gave us 2t minus 1 or plus 1 I, and plus 2j plus 3t squared k. So at time t equals 2, v will be equal to, let me see, at time t equals to, I have 5 I plus 2j plus 3 times 4, and that will give me 12k. Okay, then my v squared, like I said, is just v dot v, and the mass is what, if you remember, the mass said, we said the mass is equal to 1. Okay, so this will then be equal to, you pick your calculator, then you try to simplify. Okay, v dot v is just 5 squared plus 4 squared, 2 squared, and that is 4, plus 12 squared, and that is 173. Then half of it, so I have half 173. Okay, and that is equal to 173 over 2 joules, or in other words, there's 86.5. Okay, 86.5 joules. So that is the solution to that. Okay, now let's go to the next question. Next question is, a particle of mass 2 kg moving in a space. Okay, moving in a space has velocity at any time t given by the mass of the particle here is given as 2 kg. The velocity at any time t is given by this. Determine the magnitude of the force acting on the particle at the start of the motion. So at the start of the motion, t is equal to 0. You should always know these ideas or these stuffs. Okay, if the particle started at the point 1, 0, 0, find the position vector or the position after t equals this. Okay, so what will happen here is, you write your velocity back. The velocity is equal to t squared, then plus cos 2t, then I, okay, minus e to the power minus t j plus 2t plus 1 k. Okay, then we said the mass is equal to 2 kg. So in order to find my force is simply ma. Okay, you should find ma first before you come and find the magnitude of the force. Okay, I hope you get the point. So this is equal to the force. Okay, meaning that, but we know that our A is also equal to dv dt. Okay, so it means very simple, my force is equal to m dv dt, which is equal to 2 into differentiating the velocity with respect to time, and that will give me 2t minus 2 sine 2t I plus e minus tj and plus 2k. Okay, all multiplied by the mass m, which is the 2 kilograms. Okay, so at the start, the question says at the start of the motion t equals 0. So at t equals 0, at t equals 0, I have my f to be equal to 2 into this whole thing will give me 0, but this will give me 1 plus, okay, so this will give me 1 plus e to the power 0 will give me 1, then plus 2k. So I have 1j, so it becomes j plus 2k, and then when I multiply the mass through it, I'll get 2j plus 4k. So the magnitude of the force, which is this, is equal to the square root of 2 squared plus 4 squared, and that is equal to the square root of 4 plus 16, and that is root 20, and root 20 is what, 2 root 5 newtons. Okay, I hope you get this. So that's very simple. Now the next question is, you should find the position at time t equals pi over 2 where the particle started from here. Okay, so what will happen is, we know the velocity, and it was the thing that was given to us in the question. So velocity is t squared plus cos of 2t I minus e minus tj plus 2t plus 1k. Now the position vector is equal to the integral of v with respect to t, and that will give us, when I integrate the first term, I'll get 1 over 3 t cubed plus 1 over 2 sine 2t. When you integrate sine, you get, when you integrate cos, you get positive sine. Okay, but I have to divide through by the differential of the function in there. Then plus e to the minus tj, because when you integrate e to the minus t, you get negative e to the negative t. When you come and put it here, it becomes plus. Okay, then plus the integral of this side, that will give me 2 over 2 t squared plus t, then k. But 2 over 2 give me 1, so I have to erase this and write t squared like that. Okay, I hope you get this. So that is it, and I think that is all, plus a certain constant, let's say a. But we said that at the point of starting, okay, that is when t equals 0, the position vector there was 1, 0, 0. Okay, meaning that if I put 0 in place of this, the position vector should give me 1, 0, 0. Okay, so therefore the position vector, let me rewrite it for you to see it clearly. I have this plus half sine 2t, then I plus e to the minus tj plus t squared plus t, then k, all plus a certain constant a. So at time t equals 0, I have to put 0 in place of t wherever I see t in this. Okay, all these, then equate it to 1, 0, 0. And 1, 0, 0 is the same as I plus 0j plus 0k. And we are saying this should be equal to, when you put 0 in place of t, when I put 0 here, I'll get 0. When I put 0 here, I'll get 0. So I'll get 0i. And put 0 in place of here, I'll get plus j, that is e to the power 0 will give me 1. And plus here will give me 0 plus a. So it means that a here will be equal to this 0i, so I don't consider that one. Then I have to take this j to the other side. I have I minus j plus 0k. So it's simply I minus j. Okay, that will be my a. So I come and put the a here and add it to the position vector. So the position vector will be equal to 1 over 3 t cubed. Okay, 1 over 3 t cubed plus half sine 2t, then I plus e to the minus tj plus t squared plus t, then k, plus our a, and the a was what? I minus j. So my position vector should be equal to 1 over 3 t cubed. I'm adding the I components to this side, okay, plus 1, because I have only one I here, okay, then I plus e to the minus t, then minus 1 j plus t squared plus t k. And the question is, if you find the position at time t equals what? Pi over 2, right? So meaning that at time t equals pi over 2, I have r being equal to 1 over 3 pi on 2 cubed plus sine of 2 pi on 2 times pi on 2. Like I said, you can leave your calculator in irradians and that will give you 0. Okay, so it becomes plus 1, then I plus e to the minus pi on 2 minus 1 j, then plus pi on 2 squared. Okay, and that will be pi squared over 4 plus pi over 2. Now realize that when you simplify this part, you get pi cube over 8 all times 1 over 3, and that will still give you pi cube over 27, right? Sorry, 8 times 3 will give me what? 24 rather. Okay, so I have pi cube over 24 here plus 1. Okay, so I have pi cube over 24 plus 1, then this. So this is the position of the particle at time t equals pi over 2. Now let's go to the next question. The next question is saying that a particle of mass 0.5 kilogram moves in a force field with the force field is given by this. Okay, the force field is this. Okay, now find a particle. The question didn't come. I didn't actually complete the question, so the particle starts at the origin. So the down here, let's read from here. The particle start at the origin with velocity I minus j plus 2k. So this should be part of the question. So now we're supposed to find the position of the particle after 1 second, obtain the angular momentum of the particle about the origin after 1 second, and we determine the torque of the force about the origin after 1 second. Okay, so we have to write our information. You have mass to be 0.5 kilograms, and we have the force, or we said at the start of the particle, that is at point t equals 0, we have velocity to be equal to I minus j plus 2k. Okay, that's the v of 0. Now the force field is given by 3t squared plus 1, then I plus 2j minus 4tk. So what will happen here is that you're supposed to first find what the position of the particle. So the position is r, which is equal to integral of v dt. Now we don't know v yet, so we should just find velocity first. But before that, we know how to use velocity or acceleration to find velocity. So from this force formula, we said that force is equal to ma. Okay, meaning that my force or my a is equal to F divided by m. So I have to just pick all these components, divide by 0.5, which is our kilogram. That is the mass. So you divide each term by 0.5. So 3 divided by 0.5, I have 6t squared. 1 divided by 0.5, I have 2. Then 2 divided by 0.5, I have 4j. Then minus 4 divided by 0.5, 8tk. So you can point these on your calculator. Okay, this is my acceleration. Now I go to the velocity. The velocity is equal to integral of a, okay, with respect to t. Now this is equal to integrating every term here. I'm doing it straight away this time. Okay, so 6 over 3 t cube, and that will give me 2t cube and plus 2t I plus 4tj minus 4t squared k. Then plus a certain constant, let's say a. But we said at the point where t equals 0, we have v of 0 equals I minus this point. Okay, so let's put that one to find this. So I minus j plus 2k is equal to putting 0 in terms of t here, and I'll get 0i plus 0j plus 0k plus a, meaning that my a is equal to this. Okay, so I can simply say that my velocity is equal to, in terms of a, I'm adding everything, so kindly bear with me. You just go and add this to that, okay, and add them component wise. Okay, so we add a component of this I to the component of this I. Okay, let's do that quickly, and we'll have to get something like 2t cubed plus 2t plus 1 I. Okay, so after adding a to it, this is what you get, j, then plus 2 minus 4t squared k. Okay, I think, yes, I think that will be it. Yes, I have my k here. Okay, that's my velocity. Yes, this is my velocity. Okay, so let's go ahead and find our position. The position is r is equal to the integral of v with respect to t. So these are just polynomial functions in terms of t, so I just integrate them straight away, and this one will give me 1 over 2t to the power 4. Okay, when you integrate this, you have 2 over 4, so that is 1 over 2 plus t squared, okay, plus t, then I, plus 2t squared minus t, then j. Okay, I hope you get this. Then plus the last term will be 2t minus 4 over 3 t cubed, and k. So this is my position vector plus a certain constant a. Okay, now we said that the body started from what? Find the position of a particle after 1 second. Okay, so a particle of mass this. So with the second sentence I have here, the last one at the bottom here, it says that the particle start at the origin with velocity. So when it starts at the origin, t equals 0, and then r is also equal to 0, the 0 vector. Okay, when you put r equals 0 here and you simplify, wherever you see t, put 0 there. So we have r of 0 should give me 0 from at the origin. I mean, we said the body started from the origin, and you put it here, you get a to be equal to 0, because you put t equals 0 in all of these terms or these components, and get 0 here, 0 here, 0 here, and it's equal to 0, plus a is equal to 0, and then you eventually get a equals 0, right? So we don't need to waste our time on this, and that we have to just clean a, because a is what? 0. Okay, very simple like that. So this is our t, or this is our r. So we should simplify r at a point where t equals 1. So at t equals 1, just put 1 in place of t. So I have r being equal to simplify this, putting t equals 1, you have 5 over 2 I plus 0j, or is it 0? No, plus j rather, because I have 2 times that minus 1, and that will give me j. And simplify the last one, you have plus 2 over 3k. So you realize that this is very simple, right? But then the work is very tedious. So the next question, that is a B, is asking us to do what? Obtain the angular momentum of the particle about the origin after 1 second. So after 1 second, there's our r, you keep it. The angular momentum is r. Okay, this is r cross p, where our p is what? P is equal to our p is this. Where is our velocity? This is our velocity. Okay, p is equal to mv, and m is 0.5, and your v at t equals 1 second. So we are doing everything at t equals 1 second. Okay, so at t equals 1 second, this is the a. The first part is a. We should find this. We are done with that. Now we are going to the second part, which says that we should find the angular momentum v at t equals 1 second, or p. The angular momentum L is equal to r cross p. All of these evaluated at what? T equals 1 second. Now p is equal to mv, which is equal to 0.5 into the velocity evaluated at the time t equals 1 second. And then when you do that, you have to get 5i plus 3j minus 2k. This is what you will get. Okay, when you just pick your velocity vector, put in t equals 1 second, and simplify. Okay, when you finish everything, multiply through by 0.5. okay, when you multiply through by 0.5, you get this to be 5 over 2i plus 3 over 2j minus 1k. So just scale like that, and we know our r is equal to 5 over 2i, then plus j plus 2 over 3k. So L, which is equal to r cross this, I said that you just write the first vector from the second component, 1, 2 over 3, 5 over 2, 1. Then go to the second vector from the second component as well, 3 over 2, negative 1, 5 over 2, 3 over 2. And you cross these. I said that you just pick this and this minus this times that. Okay, when you do that, the first component will give you negative 16 over 3i. Then this one, this times this minus this times that. Okay, and that one too will give you 38 over 3j. Then the last one, this times this one minus this times this. Okay, you have to get plus k, that is 1k. So your angular momentum in effect is equal to what do I write this? Okay, let me write it here. Okay, this is equal to let me see. This angular momentum is equal to, I hope you remember the steps we did, 16, or negative 16 rather, minus 16 over 3i plus 38 over 3j plus k. So that's your angular momentum. And the last question for this was determine the torque of the force about the origin after 1 second. And the torque is just r cross f. And we know the force was given in the question. So what we just do is just simplify the force at a time t equals 1 second. Okay, so force at a time t equals 1 second. The force was already given as 3t minus something. I don't know if the force, this is the force, so let's do it together. 3t squared plus 1, and that will give me 4i. Okay, then plus 2j minus, when t equals 1, I have 4k. Okay, so I'm going to write this this 4i plus 2j minus 4k. Okay, to have 4i plus 2j minus 4k. This is your force, and you know that R is also equal to 5 over 2. All of these we are doing them under sorry, I think I really messed up here. This cross product wouldn't be this, so let me like I said, you already know the formula already, so let me write the final answers here. I think the correct answer is minus 2 here. Okay, minus 2i plus 25 over 6j plus 5 over 4k rather. And this one, the solution I wrote was actually for the torque mode. The torque rather. Okay, so let's go ahead and so this is your angular momentum, please. Okay, let's go ahead and write for the torque. This I, then this one is plus j plus 2 over 3k. And when you do the cross products properly, please, this time I won't do it with you. You have to just do it with your calculator and the rest. And this will give you minus 16 over 3 I plus 38 over 3 j plus k. This is actually the torque, and the other one is for the angular momentum, so kindly take notes. Okay, so I think you have the last but one question. Just last but one question, and I think these questions are very short. So a particle of mass, the first one is a particle of mass 0.2 kilogram is acted on by force of 5 newtons in the direction 3i plus 4j plus 5k. Now there is a force in this direction. There is a force direction, and there is a mass 0.2 kg. What is the acceleration of the particle? Okay, so to do this, very simple. Mass information given are the force, the magnitude of the force is 5 newtons, and then the mass is 0.2 kilograms. Okay, so I have to write my mass, which is equal to 0.2 kilograms, and then the direction of the force, let me call it FD, is equal to 3i plus 4j plus 5k. Okay, so there is the direction of every force that is acting on a particle. Okay, so what we have to do is we have to find a unit vector of this directional force. Okay, so sorry, this shouldn't be cap, it should be like this. So FD cap would then be equal to 1 over the magnitude of this, and the magnitude of this is just 5 root 2. So 1 over 5 root 2. Okay, 1 over 5 root 2 into 3i plus 4j plus 5k. And I hope you know how to find the magnitude is just the square root of 3 squared plus 4 squared plus 5 squared. You add all of these, find the square root of that, and that is it. Okay, so therefore what will be the force, okay, of this, the vector force of this 5 Newton force? Okay, so the vector force of the 5 Newton force will be equal to 5 Newton times the FD cap, okay, times 1 over this. So I'm just coming to multiply everything here. When I multiply 5 through this, I'll just have 1 over root 2 into 3i plus 4j plus 5k. And there's my force. So now you are coming to find our acceleration. You know that F is equal to ma. Okay, this means that my A is equal to F over m. So I take this force divided by the mass 0.2 kilogram. Okay, so you take this divided by 0.2 kilogram, you get A is equal to 1 over 0.2 times the whole of this, and that will give you 1 over 0.2 is 5. Okay, is it 5? Let me point it on a calculator so that we all see it. 1 over 0.2 is 5. Yes, it's 5. So 5 times this will become 5 root 2. I mean, just pick your calculator, divide every term by this, okay, and in effect you get what I'm coming to write here. You get your acceleration to be like this, okay. So the question gave us what is the acceleration. So this is the acceleration, very simple, like this, okay. You can go ahead and simplify if you want to simplify, okay. So that is it. Now we go to the second point. The second point is you find the velocity, and we know that v is equal to the integral of a dt, okay, integral of that. So I just pick my a which is equal to 5 over 2 5 over root 2, sorry, then 3i plus 4j plus 5k. So 5 over root 2 is actually a constant, so I just come in, put it out there, then v will be equal to 5 over root 2, then 3ti plus 4tj plus 5tk plus a certain constant, let's say a, okay. But in the question says that the b, if the particle has velocity 2i minus k at the start of the motion, finds its velocity at time t equals 2 seconds, okay. So starting at t equals 0, we have velocity being equal to 2i minus k. Let me write it to 2i minus k. So this simply means that my v of 0 should be equal to 2i minus k, and that should be equal to putting t to be equal to 0 in place of all these. I have 0i plus 0j plus 0k all plus a, okay. So here all of this part will go to 0, so it means that a is actually equal to 2i minus k, okay. So let me erase this and put it there, that a is equal to 2i minus k. Alright, so I have a being equal to 2i minus k. This means that my v is equal to 5 over root 2, then 3ti, okay, plus 4tj plus 5tk, then plus 2i minus k. So if you want, you can actually multiply 5 over root 2 through this and add the corresponding component to the 2i minus k. But we don't actually need this. We need the velocity simplified at time t equals 2, right? So we just put t equals 2 here, and then you have v being equal to 5 over root 2 into 6i plus 8j plus 10k and plus 2i minus k. Then we can actually simplify this, okay. So we know that 5 over root 2 is the same as, so the velocity at time t equals 2 seconds is equal to 5 over root 2 is the same as 5 root 2 over 2, okay, then into 6i plus 8j plus 10k and plus 2i minus k. So you multiply through that, and what you get is 15 root 2 I plus 20 root 2j plus 25 root 2k, okay, all plus 2i minus k. And this will give me, simplifying the I or grouping the I have 15 root 2 rather, okay. So 15 root 2 plus 2i plus 20 root 2j plus 25 root 2 minus 1, okay, then k. So this is your velocity at time t equals 2 seconds. I hope this is very simple, right? So let's go to the last question for this lesson, and that will be all. Okay, so the last question we have: a particle of mass m moves along a space curved defined by r of t. So our position vector is defined by this. Now, a cos omega t I plus b sine omega t j. Calculate the magnitude of the force on the particle. So a particle of mass m, the mass is m, okay, and this is the position vector. So the first one, what you do is mass is equal to m. So the information is mass is equal to m, and we know that the position vector a is, or r is also given as this. R bar is equal to a cos omega t I plus b sine omega t j. Okay, now the first thing is we should find the force, the magnitude of the force. Now F bar, that is the first part. F bar is equal to ma, is equal to mass times acceleration, and acceleration is simply the second derivative of r. So I have to differentiate r 2 times. I have m into, so, or you can say acceleration is the derivative of velocity, and velocity is the derivative of position. So we have to, if I differentiate the position 2 times, I have acceleration. Okay, the first derivative of this with respect to time, I'll have, okay, let me write it this way: dv dt. Okay, so that you all understand. So m, the mass is m, and we know that dv dt, so I have to find d, let me do it, m times d dt of the velocity. Okay, the differential of the velocity, and velocity is dr dt. Okay, so let me put it this way so that we go through it together. M into d dt of, now r is what this, when differentiate with respect to t, differentiate the whole of this with respect to t, I'll have minus a omega, then sine omega t. Okay, omega t, then I, plus b omega cos omega t. We are differentiating with respect to t, so wherever I see a function of t differentiate, so I have to differentiate this omega t to get omega, multiply by the differential of sine, which is cos. The same thing happens to the first term. Okay, and this will be equal to m into d dt of the whole of this again. So I have minus a omega squared, because I have to differentiate this sign, and I'll get cos. Okay, I'll get positive cos, but already there's a minus. Okay, but there's an omega here, and when I differentiate the omega t again, I have to get another omega. So I multiply, I get omega squared, sorry, then cos omega t I plus, when you differentiate cos, you get minus, so I have minus b omega squared sine omega t, then j. So this is my force, minus ma omega squared cos omega t minus mb omega squared sine omega t j. So this is my force. Okay, the magnitude of the force is simply the square root of the components summed. Okay, so magnitude of F, that's the question you should find, is equal to the square root of, you square each term, then you sum them. So you square minus of this, that will be positive. So I have m squared a squared omega to the power 4 cos squared omega t. Okay, plus m squared b squared omega to the power 4. I'm squaring everything. Omega is already squared, so when you square, you get omega to the power 4 sine squared omega t. When you look at this, I can factor m squared omega to the power 4 out from each of these. Okay, so I have magnitude of F being equal to the square root of m squared omega to the power 4. Then I'll have a squared, okay, a squared cos squared omega t plus b squared sine squared omega t. Okay, so I'll have m omega squared, because the square root of this will give me m omega squared. Then square root of a squared cos squared omega t plus b squared sine squared omega t. So now let's go ahead and look at something. What is r? R is this. Okay, a cos omega t plus a cos omega ti plus b sine omega tj. Find the magnitude of r and c. The magnitude of r, we can rewrite it as just r without the bar, and this is equal to the square root of a squared cos squared omega t plus b squared sine squared omega t from the question. So it means that this whole part is r, that is the magnitude of r without a bar. That is in vectors. If you write a vector without a bar, it's just the magnitude. Okay, so it means that our force, the magnitude of our force, is equal to m omega squared r. Okay, so you can keep this. Now the second question is, you should find what the angular momentum, okay, the angular momentum of the particle about the origin at any time t. Now I know that angular momentum L is equal to r cross p. Okay, r cross p, and r is given. P is also equal to mv. Okay, but the v, we had it when we were solving the force. The v is just the differential of r with respect to time, and that gave us this part. Okay, so that is, or you can actually differentiate it again. Okay, r is already equal to a cos omega t I, then b sine omega tj. Okay, v is equal to the differential, which is minus a omega cos omega t, sine omega t rather, sine omega t I plus b omega cos omega tj. That's my v. Okay, and this is my r, but my mass is still m, so my p will simply be equal to minus am or ma omega sine omega t I plus mb omega cos omega tj. Okay, so when I find a cross product of this, r is that. Okay, so I have to write it in 3 dimensions before I can do that. Then L will be equal to r, when I add plus 0 in the k direction, this one to add plus 0 in the k direction. Okay, and L will be equal to, starting from the second term of r, is b sine omega t, then the third term is 0, the first term is a cos omega t, then b sine omega t again. Like I said, just write it from the second term, come and end it at that same term. Now I come to the momentum, we have m b omega cos omega t, then we have 0, okay, and we have minus ma omega sine omega t, and we have mb again omega cos omega t. Like I said, you just do this and this minus this and that, and that will give me 0i. Then this and this minus this and that will also give me 0j, because 0 times 0 times this will give me 0, 0 times this will give me 0, then plus this times this minus this times that. Okay, that's the angular momentum, right? So I have this times this is a mb omega cos squared omega t. So I have a mb omega cos squared omega t plus, minus. Okay, there's a minus already here, so minus, so I'll have plus a, there's an a here, okay, there's an m here, M, there's also a B here, B omega, then there's a sine, so I have sine squared omega t. Then that is in the direction of what? The K. So this is equal to, for the J and I, they are just 0. So I have A and B omega here. Then I factor that out. I'll get cos squared omega t plus sine squared omega t, and that will definitely give me 1. Okay, so I'll have to get my angular momentum to be equal to A m b omega, and that is all. A m b omega in the K direction. Okay, or if you want to write the mass first, you get m a b omega in the K direction. Or some books wouldn't bring the K because it's just one direction. Now the last one is to obtain the torque of the force. Okay, the torque is simply R cross F, and you know F, so torque is equal to R cross F. We know the force F and you know the R, so I'll just quote them here. R is equal to A cos omega t plus B sine omega t cross, let me write this 1 2 here, minus MA omega squared cos omega t minus, there's an I here, there's a J here. Okay, so I minus MB omega squared sine omega t, then J. Let me add the 0 parts. Okay, like we said, we should get a 3 dimension. J plus 0k, then cross this. Now this is equal to, I said write the first one from the second component, so B sine omega t, then 0. Okay, then the next A cos omega t, then I end up at B sine omega t. Then I come to this part, minus MA omega squared cos omega t. Sorry, you said we should write from the second part, right? So it's minus MB omega squared sine squared or sine omega t, and 0, then minus MA omega squared, okay, cos omega t. Okay, then you end up at that same place, minus MB omega squared sine omega t. So you realize that this time this will be 0 minus this time is 0, so I have 0 I plus this time this is 0 times this time that 1 2 is 0 0 j. I realize that this time this will give me A minus A something. Okay, I have minus A MB omega squared cos omega t sine omega t. Okay, then minus this time this, but you realize that there is a minus here already, so it becomes plus. Okay, so it becomes plus A MB omega squared cos omega t sine omega t. Okay, so they are the same. When you add this minus of that is plus. When you add, you get 0 of the K component. So you get, in addition, the K also vanished to 0. Okay, I'm sorry, I want to erase this part for you. The K will also tend to 0 as well. Okay, so in addition, I have plus 0k. So in effect, the torque is 0. Okay, I hope you understood the process we went through. So these are some of the questions I have with you, and then I'm hoping that I'll get time to also go through the potential energy, how to also use that to find your force field and the rest. Okay, thank you, and like I always say, don't forget to subscribe to my channel if you have not subscribed. Okay, just like my video, comment, and also share it as well. Okay, see you next time.